This video is going to serve as an introductory video to the beginner course that I'm going to give for you guys here on YouTube. This is going to be pretty much just delving off into the basics of subwoofer enclosure design and kind of simplifying some of the more complex builds that you can have in car audio. What you guys are looking at right now is a sealed enclosure. This is the most simplistic enclosure that you can build in terms of, I should say, complexity. Sealed enclosure, nothing too much about it other than staying within manufacturer specification, and you should be okay. This is to spec, and it will be fitting a 4-inch driver in case you guys are wondering about that. The driver that I'm going to be using in all of these subwoofer enclosures in this series is going to be the Dayton Audio TCP 115. This is a 4-inch woofer. Not exactly a dedicated subwoofer, but you can take a speaker and do whatever you want with it. And with it being a woofer, you can actually use it as a subwoofer more easily than you could if you were to use a speaker. So technically all subwoofers are speakers, but this is dedicated for bass extension. We're just going to be using it for sub bass extension, which it wasn't particularly designed for, but you can still use it as such. Moving on, what you guys are looking at is a classic bass reflex enclosure, or what some would call a ported enclosure. This is the next in line. And to be honest with you, the way this series is going to go is you always have to have a control, right? When testing out different types of anything. So with that being said, the first video of the series is going to be a comparison in between sealed and ported enclosure. Different sound signature and behavior and how that affects the movement of the cone, of the subwoofer, and temperature. Next up, what you guys are looking at is what is called a horn enclosure. This horn enclosure is designed after the front-loaded horn enclosure. Most people would call this a folded horn enclosure. But as you can tell over here in the corner, this is a sealed section. It incorporates a sealed section with a horn or waveguide attached to the front of it. Some people call this, I believe, a bass scoop. You would also see people calling this. These are very popular for concerts and such. Also, the tap horn enclosure is also very, very popular for concerts because with a waveguide design such as this, they're very directional. But I just kind of wanted to show you guys the difference, not only in size, just of these three different enclosures, but the way that it's incorporated. Once again, this front-loaded horn enclosure has a sealed section and it has a line attached to the front of it. Moving on, and the reason why this port piece is loose is because this speaker would not fit in here otherwise. So this has to be detachable in order to make that work, in case anyone was wondering about that. Next up is going to be the 4th order bandpass enclosure. We're going to have two different types of bandpass enclosure here on during this series. Okay, once again, the bandpass enclosure also, the 4th order bandpass enclosure also incorporates a sealed chamber. It's a sealed chamber with the ported section. So you have two different enclosure types, meaning they have taken these two types, which is a sealed enclosure and a ported enclosure, and incorporated them within one. It houses one driver. Two style of enclosures married for one driver. And the reason why people would do this is for bass extension and SPL as well. So you pretty much are taking advantage of the sealed enclosure's capability of low end extension, a very slight roll off, gradual roll off, and you're going to couple that with the efficiency of an actual bass reflex enclosure. Pretty cool design. The cousin to this design, some would say, would be the 6th order bandpass. These are the two most common bandpass enclosures that you would see in car audio. 4th order bandpass, 6th order bandpass. Of course, as you guys can tell, the 6th order bandpass has two ported sections that incorporate one driver. Okay, I should say one baffle, because you can put multiple drivers on this baffle if you want to, just as long as it has one baffle with two different sections. This is a bandpass enclosure. This is what the front of it looks like. It has 2 slot ports on the front of it. And the reason why people would incorporate a 6th order bandpass is mainly for frequency range and extension. This extend the range of your frequency response. So if you have a regular sealed enclosure and it gets low as around, say, 40 hertz, or maybe it digs into the 30s a little bit, and you're wanting it to do a little bit lower than that, you can actually tune one of these sections as low as you want to, and then you can cap it over here with another frequency. You can turn this to 20 or 25. You can tune this one here to 50. So you'll have a frequency range that digs into the 20s and into the 60s. So you'll have a frequency range of mid 20s all the way to mid 60s with complete cone control. This ported enclosure cannot do that, and a sealed enclosure cannot do that. Depending on what driver you use with the a 4th order bandpass, they can sometimes do that, but they will not have an extended frequency range such as the 6th order. This is your SQ application as well as SPL application. Most people incorporate them for SQL applications. Again, these are going to be just a few of the enclosures that we're going to be starting out with in this miniature series, and hope you guys stick around and learn with me. All right, so right now what you guys are looking at is the flat pack. This is a flat pack to the bass reflex enclosure, and this is what it looks like. So just imagine if this was for a 12-inch subwoofer enclosure, you would know that this would be probably an entire 8-foot by 4-foot sheet of plywood or MDF. In my case, this is MDF. I prefer that over plywood, but that's not the point here. The point is the process in which you go about when building. What you just seen was the dry fit, which is very important. You want to make sure all your pieces line up correctly. And once you get your dry fit and you're happy with that, it's time to do some additional cutting. Right now I have the baffle piece here, and it has a schematic laid out on the front of it, because you need to know where this thing is where your screws are gonna screw into, and where is the wood in which to screw it into. Right now you see me shading an area. That area is gonna be the port. I need to get that carved out, as well as using this circle jig you see on the screen in order to cut the hole out for the driver itself. In case you guys are wondering, this is the Jasper jig. The Jasper jig is very, very handy when cutting out holes. It gives you perfect holes. This one here in particular actually gets holes it creates holes from 2 inches all the way up to 18 3/16 of an inch. Pretty handy tool. And as you guys can see here, it made very short work of what this little guy needed. Was I believe a 3 3/4 inch or something like that. 3 3/4 inch of a cutout, and did that perfectly for me. Fits snug like a bug in a rug. Pro tip: these little cutout discus right here are very, very handy whenever you need extra bracing inside a cabin. Never throw those away. So what you guys is looking at is me once again doing my dry fitting. You do see that I have all the pieces labeled, but even though I've dry fitted this once before, I did do some trimming and cutting on this. So anytime I cut or round over anything, I always go back to make sure things look good. And that's pretty much what I'm doing right here. Yep, everything looks good. The hole is looking beautiful. Like I said, perfect hole with the jig. Still need to cut this, the opening for the port piece, but other than that, the roundovers look good to me and everything pans out. So this dry fit is successful. We can move on to the next piece. Now it's time for the glue up. The glue up is always fun, but just notice what I just done here. I want to point this out to you because I feel like this can save you guys some time and effort. These are the inner port piece, okay? The inner walls of the port itself. And I'm gonna tell you from experience, especially when you're doing full-size enclosures, it is very, very difficult to put enough pressure on these pieces to get them glued and screwed once you have the walls up. So what I do is I always put them together like you see here now, and then I can just use it as puzzle pieces, right? So I don't have to worry about the walls getting in the way of, you know, whatever device I'm using to clamp pressure down on this thing, because it's already put together. It's already a one piece. So this is just a little pro tip for you guys. I got my walls glued, and I already put the brad nails in there, and there you go. I can just slide this port right on in. With this being such a small build, this would be very, very much easy to do just for pressure fitting. So I can just lay something heavy on top of it and it'll do its thing because it's such a small scaled item. But just know that I probably could have saved myself even more of a hassle if I would have just glued and bradded the port first. Once again, the name of this driver is the Dayton Audio TCP 115, and I got to make a gasket for this thing. I have a couple enclosures that I'm going to build that's going to require some airtight fit. That is the sealed enclosure and that of the front-loaded horn enclosure, because they both, of course, incorporate a sealed section. The 4th order bandpass does as well, so I have to make 3 of these. And the way that I'm going to do it is what you're seeing now. I just took a piece of old shop mat and I used a razor and a little bit of this glue stick. This stuff, believe it or not, comes in handy. I fabricate so many things using this. It wouldn't be funny behind the scenes. You guys will probably laugh like, okay, budget based show use a lot of that glue. I'm talking on carpet, amp rack, you're talking wire cable management. I use this stuff all the time. But as you guys can see here, I'm using it as a gasket, not the first time, and it came out perfect. I like it. It's nice and thick, which means that you're going to get a whole lot of compression, and it's just going to minimize any air leaks that may be possible. Right now, what you're looking at is that shaded area right there. That is going to be the port. I wanted this to be a single face, one flat piece for the face of the subwoofer enclosure. So that's what I did here. And when you do it like that, you have to use pretty much a punch router, or in this case, what I'm using is a drill bit. And you want to go ahead and drill that out. This is a 1/2-inch bit, so you're going to need a 1/2-inch shank. No, well, not a 1/2-inch shank, but a 1/2-inch flush trim router. And that's what I'm going to do now. I'm going to go ahead and get that in there. And once we get there, we're going to get the router and just bore this thing on out. If you guys are wondering about any of the equipment that's used here in the video, you can just look in the descriptions below, and I'll have some links in case you guys want to check it out. All right, now that we struggled our way through boring this thing out, what we're going to do now is apply a round over to the port. Remember, this is a base reflex enclosure, so the port, you kind of want everything flared to ease airflow. Okay, so that's what I'm doing now, using that 1/2-inch round over bit, and I think it turned out pretty cool. Now comes the part where every cabinet builder wish they can just skip, and it's sanding. Sanding is messy, it is loud, but man, does it reap a beautiful, beautiful reward. So that's kind of what I tell myself once I'm doing the sanding, is that I know once I'm finished that everything is gonna look very, very good. And as you guys can see, this 80 grit is pretty much erasing all those imperfections that I had on the outside of the cabin. And that's kind of what you want. Yeah, it can be a pain, but the reward is worth it. Now it's time for the sealed enclosure, and this is the flat pack after I got through cutting everything. And as you guys can see, it's not much more than that of the ported enclosure, because I wanted them to be similar sizes. And now it's time for the glue up. The glue up here is going to be pretty straightforward. No ports or any angles or anything weird like that going on with a sealed enclosure. So just make sure all your edges line up correctly, clamp them down, and then get the brad nailer out. Once again, sanding is pretty straightforward. Just make sure you get rid of any glue or raised edges that you may have in terms of imperfections, and make yourself a smooth surface. That's all you want. You want smooth walls all the way around, and that's the objective here. And now it's time for wiring. Right here, what you guys are looking at on the screen is two different wires, and I'm going to show you how to make a twisted pair out of this. So twisted pair, why a twisted pair? Well, sometimes when you're running signal cables or speaker cables, sometimes you can get this interference, right? So what interference I'm talking about is the vehicle hum that comes through the speakers, through the wires. And a lot of people don't understand that, yeah, bad ground could definitely be the culprit, but a lot of times it's because you're running your signal wires a little bit too close to power wires. So I make a twisted pair just using your chuck on your drill bit. Next up is speaker terminals. This is going to be very simple. I'm just using 2 bolts sticking out of the side of the cabin. In order to do this, I'm going to just take a drill bit that's slightly smaller than the diameter of the screw, and then I'm going to force the screw through the wood. MDF is fairly soft, So you can get away with doing this and actually create a threaded insert or a threaded channel for your screw to fit through. And like right here, you can see me actually get that thing started with my hand, and then I use the 90-degree angle driver to drive it on home. This actually ensures an airtight fit, which is very, very crucial, especially when you're dealing with sealed enclosures. Right now is the female connectors that's going to slide onto the spade connectors of the woofer itself. I bought these things off Amazon. Anything that you see me use here in the video can actually be purchased through the affiliate links down below. So check the description and hopefully you guys will find something that you need. And for the ported enclosure, this is just going to be a rinse and repeat. Same thing for the sealed goes for the ported enclosure. So make the twisted pair, connect the connectors on here, and then add your woofer. And that's pretty much it. Being that this is a sealed enclosure, I wanted to get this thing stuffed. This is just customary with sealed enclosures because to me it does give it a more warmer signature to it or tone to the woofer, to the driver, and it actually is supposed to help with compression inside of the chamber as well. So I add a little bit of cushioning in there to cut down on a lot of resonance that you get from sealed enclosures of this size as well. Now come one of the most rewarding portions of building a cabin, and that's drilling those pilot holes to mount the driver. Mentally, you know that the sooner you can get this thing mounted, the sooner you can start playing with it. And this is my most favorite part of any of the builds that I do. Once again, rinse and repeat for the ported enclosure. It gets stuffing inside of it, it gets the gasket, and like I said, even in a ported enclosure, you do want to treat the internals of it some way. For me, it's a preference because I like the warmer tone that it creates. So there you go, cut down on the resonance, give a softer tone, and we're done. I like to take this time to announce the launch of my first merch store. This is budgetbasedmerch.store. We have t-shirts, hoodies, hats, and cups. Hopefully this here will give you guys another way of being able to support the channel. You have asked for this for a long time, and here it is. Hope you guys like what you see. Thanks in advance. All right, guys, as you can see, we do have the sealed enclosure and the ported enclosure connected. Everything's fired up. Now all we have to do is make a few adjustments on the setting of the door speaker amplifier. This is the Taramps DS 440x4. This amplifier here is actually running the front stage. These guys are off camera. You don't see them, but you will be hearing them. They are what's going to be playing the mids and highs. And this right here is going to give us our bass extension down here. So the 4 inches are going to be serving as subwoofers for the 6 inches. I know that sounds a little weird, but it's for a test, and we're just going to see exactly how well they do in the enclosure. But remember, it's not about how loud they are. It's about the sound signatures in which they produce. The sealed enclosure is going to sound a little bit different than the ported enclosure, and that is what we're here for. Another thing we're going to be doing is we're going to be looking at the cone control, the behavior of the cone of the ported enclosure versus that of the sealed enclosure. Their behaviors are a little bit different. So that's what we're checking for. We're not checking for loudness. This is not an SPL competition, okay? This is a learning experiment. This is your lab, all right? Anyway, so the adjustment that we're going to have to make on this amplifier, if you guys can tell, they have 2 sections of the amp. This has 2 channels, and this controls 2 channels of this 4-channel amplifier. You can look at the crossover section right here, and it has a high pass stage, a full range stage, and a low pass stage, meaning that you can use this amplifier just for mids and highs. You can use it as a full range speakers if you have full range speakers, or you can just use them as bass speakers if you want to use them for bass speakers. People buy this for different reasons, and to have that versatility is very, very important, especially in a setup like this, because we don't want these speakers playing bass. We want them to play our bass. And what we're going to be doing is we're first going to disconnect the ported enclosure. We don't want him playing right now because we want to know what the bass sounds like coming out of the sealed section. But what we're going to do first is allow you guys to see what this sounds like as a full range, which they're coaxial, full range speakers playing bass. And then we're going to switch them over to high pass to allow only mids and highs, and then we're going to let you see what these individually do to add bass. So first of all, let's make sure that this is on. Okay, that's full range. And this is now full range. And let's push play. Name of the track is Silver Tears. Artist name Dream. I actually like this song. It sounds very, very cool. Very dynamic. Got the volume on 18 right now. Not a lot of volume at all. Whoa, let me turn this down. Sorry about that. All right, let's turn this up a little bit. All right, let's switch to high pass. Let's take the bass out. Alright, so as you guys can see, I went ahead and added my SMD AMM1. This is an audio multimeter, and what it's going to do is give us our real world power. I just want to monitor how much is going to these little guys because I don't want to bust them. They're only 4-inch drivers, guys. They're only 40 watts. This thing can put out way more than that, so I don't want to damage the speakers. Anyway, let's run that back again while monitoring how much power is actually going to the speakers. All right, here we go. This one's disconnected, as you guys can see, and that one there is connected. Let's get it. All right, let's get him connected. Wow. what they sound like together. Woo! Had to take that off. Wait a minute. Wait a minute. Wait a minute. I think that puts them in parallel, so that may have dropped the impedance a little bit. Let's look at this. Wow. That's a weird wiring configuration. So what we had this on 23? Looked like this guy started bottoming out when I added him. He started bottoming out. Whoo! What? Oh my God, they sound good together. Wow. Wow, did not expect that. 18 watts. Woo! Woo! Wow. Ooh, ooh, let me stop this. So just remember, this type of design is or does have its place, because what you got to understand is that this was a lot more bass than this. This one sounded a lot louder than this one did, and the reason for that is because of efficiency. It can get there with less power. 20-something watts, it was at its maximum, it was sounding good, but then, you know, start bottoming out. You don't want that. Very efficient design, doesn't need a lot of power. This one, on the other hand, needs a bit more power, but it sounds good doing it because of the accuracy of it. Very punchy bass, very accurate bass, okay? Not as efficient, but way more accurate. So when choosing sealed versus a ported enclosure, these are the pros and cons you need to keep in mind. Pros: smaller footprint. The cabin doesn't have to be that big. Accuracy, better power handling, okay? And more cone control. Those are your pros over here. The pros over here is gonna be highly efficient design, meaning you don't need a whole lot of power to produce a lot of sound. Another perk would be easily tunable. Because of the port, you can tune it to a specific frequency that will play within a range of bass in which you like to listen to with the type of music you listen to. Over here, it's not so tunable. It's kind of like a jack of all trade, but a king of none, right? This one right here, on the other hand, can be a lot more customizable. You can customize the tuning of this one as well. It's just not as easy as the one with a port. Okay, so you have efficiency, right? Great SPL numbers or SPL levels with less power, and it's the tunability of it for the ported enclosure. Thanks for visiting the channel to help you simplify car audio. It's the Budget Bass Head, and I'm out.